Intro to DevOps, using AWS OpsWorks and Amazon RDS. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a question pod. Please submit your questions for our presenters at any time during this webcast, and we will address them in the live Q&A session at the end of the presentation. Today's webcast is being recorded, and we will send you a follow-up email with the URL to the recording, as well as a link to the presentation deck. And again, welcome to today's webinar, Intro to DevOps, using AWS OpsWorks and Amazon RDS. Our presenter is Chris Barclay, Senior Product Manager with Amazon Web Services for AWS OpsWorks. You have the floor, Chris.
Thank you, and welcome everyone. Appreciate you taking the time to hear a little bit about OpsWorks and Amazon RDS today. So to kick it off, just wanted to answer, I guess, the first question, which is, what is DevOps? Some of you in the audience may be familiar with this or may have heard this term and might be curious to hear a little bit more about DevOps. And at Amazon and AWS, we tend to follow a lot of the principles of what folks refer to as DevOps. And so I'll tell you a little bit about how we think about DevOps. And certainly there's probably a number of other opinions and thoughts out there, and welcome you to share those through the Q&A. In general, DevOps is a number of things, but in general, it's about how to help you make your software development processes more efficient and more robust. And some of the things that we think about with regards to DevOps are the fact that we really want to deliver scalable and resilient applications, and we want to do it with less work and less risk. So the whole goal here is how do we become more responsive to our customers and be able to deliver the features that we want to do in a much more timely and efficient manner. And when we think about traditional development processes, at least when I've used to do a lot more coding than I do today, there tended to be fairly distinct teams in the environment. So there was the development team who was distinct from the testing team, and then once you were done, you handed off the code to your operational team, and there was usually various folks in operations that were oftentimes in the IT org or perhaps just different teams within development. And so each of these required you to kind of throw assets in effect over the virtual wall from one team to the next. And at least in my experience, handoffs can cause challenges. Whenever you kind of move something from one group to another, there can be challenges of who's responsible for exactly what. And even if we try to iron these sorts of things out through processes and procedures, there can be challenges, especially when there's times of trouble. So if there's a problem or perhaps some sort of issue in your application. And typically this manifests itself in things like you have a lot of success in your application, so the application's scaling up, and nobody really knows how far can that app scale, where are the breaking points, who's responsible for figuring that out, what are the right sizes of machines you want to be using to run your app. And all these coordinations can cause challenges and of course delays. And so when we think about DevOps, we're really talking about a culture of ownership. So making sure that even if you do have distinct teams, that they're working more as one unit, and that there's much more coordination and accountability, and these things can then deliver benefits like predictability and speed. So you're able to have a much more predictable delivery schedule and be able to deliver more quickly. So in order to get there, I'm going to talk about 4 different things that you ought to be thinking about when you're thinking about DevOps in general. The first is iterative improvements. The second is thinking about everything as code. The third is thinking about automation, and then, of course, practicing things that are hard. So let's talk first about iterative improvements. Today, and again, from my experience, when I was delivering code, we thought they were short release cycles. They were 6 or 12 months. But today we think of those as fairly long release cycles. And the reason why we have these long release cycles is because of the challenges I mentioned around handoffs. So we tended to think if we had short release cycles or every time we had a release, then these challenges around handoffs would happen. And if we tried to do it more quickly, then we'd just have more handoff challenges. And so these long release cycles ended up having different set of challenges, which is that it was really hard for us to be responsive to our customers, right? If you're releasing every 6 or 12 months, then you're probably finding that by the time you release, then sometimes either you didn't understand the requirements well enough or requirements might have changed, and you've batched up enough stuff that sometimes those handoffs are even more challenging because you actually have a bigger set of changes that are going to be pushed to production. And so the thinking is, if you have a constant stream of smaller improvements, then you can be much more responsive to your customers. And a side benefit of that is that you're able to actually reduce your risk, which is kind of counterintuitive until you think about the fact that if you fail a small improvement, then it's pretty easy to roll that back and try again. If you fail on a big improvement, then trying to figure out where the failure happened and take corrective action can often be pretty hard to untangle. And so agile software delivery is pretty key to thinking about how to move more quickly. So, small improvements, get it out there, and we're talking about release cycles that are days or weeks at kind of the most. So being able to kind of really make these things much more incremental. And so it's not just a DevOps principle here. You've probably heard about things like agile development. So being able to think about a feature in terms of a story, which is typically maybe a paragraph or two where you're just describing the succinct benefit that you're delivering to your customer, and being able to then have the development effort also be fairly small as well. So breaking things down, decomposing things to their essence, and if they're too big, then decomposing them yet further so that you can actually really deliver these things in a much quicker amount of time. So then you're looking at having more of a shared team between your development organization and then the folks that are actually doing the deployment. So think about those both as areas that you can create much more nimble and more incremental improvements. The next thing to think about is that today everything that you do can be code. So back when I was doing a bunch of application development, I usually thought about my app as just the thing that I compiled. So it was the end output of that was a WAR file in Java. It could be an executable of some sort. But today, your app is also the resources you're using and the configuration of the software that you're deploying your app into. So today, for example, you can define your app by recipes in tools like Chef or Puppet if you want to use configuration management tools, or even if you just want to do something pretty basic like create a bash script that does the installation of your software. And by being able to define the software that you're using in a way that's now in a script means that it's instantly repeatable. So you can hand that off to your teammates. You can hand it off to your testing organization. And when they run that script, then the exact same software gets set up as what was set up on your instances. And so that gives you a lot more repeatability. But you might be curious as to what about the resources you're using? Well, at least in the cloud, you can model your resources as a stack. So inside tools like OpsWorks and CloudFormation, you can specify every resource that you're using. So the EC2 instances that you're deploying your application onto, but also the load balancers, the databases, any metrics and alarms that you want to define. So now when you hand off your application from your development group to your test group and then onto your staging and production environment, there's no longer any changes or differences that have to happen between those two. They can be identical. And in fact, that really gives you a lot more predictability, because when people are testing exactly what is being developed, and then when you're actually pushing to production exactly what's been tested, then you have a lot less possibility for problems to creep in. So reproducibility is important, and that's really one of the key aspects of being able to move quickly. And of course, you can't have automation without having some sort of ability to reproduce environments, right? So being able to script things up and be able to ensure that you're actually performing the sequence of operations that you want. So again, back when I was doing a lot of development, we tended to kind of use a very handcrafted process. So we would kind of follow every single step, and we do it all ourselves. So we might log on to a computer, and we provision the server, log into it. We'd configure networks and storage. We'd download and install software, configure the software, and each of these things, we tended to have like a playbook or cookbook of some sort. But but it wasn't really automated. It wasn't done for us. And so, if you end up making changes to these configurations and you forgot to update the playbook, then the next group would find out that things didn't work right, and then you'd kind of have to go through that whole process of, well, what actually changed. And so doing things by hand is oftentimes, it seems like it's going to be faster, but then it ends up causing a bunch of slowdowns and rework along the way. So automation is really pretty key, and thinking about how you can use the tools of treating everything like code gives you really the ability to automate. And so what we really want to have is a bunch of robots that are now kind of cranking out the donuts that we have specified, and we can specify what flavor the donuts are, which donuts get sprinkles. So it's not that everything has to come out identical. The nice thing about automation is that you can specify exactly what you want for different components of your application, and then you can ensure repeatability and consistency of that even at scale. So as your application is scaling up, you can have this automation take care of that scaling for you, and you get a lot more speed, and you also get, with this hands-off ability, you also get consistency of the resources that are being provisioned for you. So the last thing I'll mention is it's really important to practice the hard things. So look at what's hard for you in your organization, and then go ahead and practice those. So you probably know that scaling can be challenging, so it's probably good to be able to go ahead and try to scale out your application, figure out where it breaks. The nice thing about the principles that I've just mentioned previously in the slides here are that with this automation, with the configuration that we've created, now it's really possible to create identical environments that we can then simulate load on. So we don't have to go to our production environment and try to simulate load and possibly cause problems. We can do that in a nice staging environment. And we know that we're probably going to have problems with our application, and so creating alarms on things that are important metrics is really important. So for example, with us internally, we look at things like the latency of API calls. We have a set of alarms that on all the things that we think might be problematic, and then when we see problems, then we go in and we can diagnose them before even they become visible to customers. The next thing is thinking about creating a mechanism to save your logs. The last thing you want to do is have be needing to diagnose a problem and not have logs that can help you diagnose it. So being able to kind of move logs from your machines to persistent storages like S3 is something really important to think about, and make sure those logs stick around for a while. So you don't want a log being removed after a week when you might find out about a scaling problem months later. So it's pretty cheap to store stuff, so keep logs around for a while. Permissions is important too. So thinking about who on your team ought to have access to resources and who shouldn't, so that you don't have people making unintended changes. And along with this is thinking about when you do have alarms come in, what are the sorts of activities you want people to follow? So having a cookbook that specifies for these types of failures, here's the set of things you want to walk through so that people aren't trying to figure that out at 2 a.m. And then canaries is something else to think about. So simulating user interaction on your system through a set of external inputs is something that can be very helpful to making sure that your service is operating properly. That can be everything from just hitting health check endpoints, which you can get from most load balancing software today, to actually logging in and performing a certain set of actions or flows through your application. And we find that canaries are very helpful for ferreting out problems that otherwise wouldn't be known. So networking issues that crop up intermittently, for example. And then, of course, in the cloud, it's very easy to simulate failures. So you can create these staging environments where you can turn off aspects of your application, simulate networking problems, simulate storage problems, and see what happens. And figure out then which ones of those do you want to remediate, or at least have in place a good cookbook for how you can address it in the moment. So OpsWorks is kind of the other piece of this presentation, and it's an application management service that will help you deploy and operate applications of all shapes and sizes on AWS. So OpsWorks provides a number of features that really help with application management. When we spoke with customers a couple of years ago, we realized that there really weren't many good tools on AWS to deploy and operate fairly sophisticated applications. Customers ended up having to do a lot themselves. And so what we've done with OpsWorks is we've created a tool that if you have applications that have a bunch of different types of components, whether they're fairly sophisticated in terms of their breadth or depth, you can use OpsWorks as a means by which to automate and get a lot of the DevOps capabilities we described here in this presentation. So we'll kind of go through each of these in more detail in the demonstration, but let me just cover them briefly right here. One of the first things OpsWorks gives you is the ability to provision the resources that you're using. So you're able to create instances that look exactly like what you want because you've been able to specify that instance configuration using this concept of layers inside OpsWorks. You're able to deploy your application, whether that's from a Git or Subversion repository or even just from an S3 or HTTP bundle. We let you create this concept of modeling your application. So you can specify each of the core components of the app, whether that's load balancers like HA proxy, databases like RDS, caching layers like Memcache. Basically anything that you have inside your application as a component, you can model as a layer. We let you auto-scale your application so you can scale that up and down without needing to have interaction with that, so that can happen based on time or load. We give you the ability to control the permissions for what users can do on your resources. You have deep monitoring using Amazon CloudWatch. We push logs for you to Amazon S3. And then we let you manage those resources so you can specify things like RAID levels for EBS volumes and elastic IP addresses. So we'll talk about all this in more detail, but a lot of the concepts we've just covered in this presentation are pretty straightforward to do with OpsWorks. So you might be asking yourself, well, why would I need a tool like OpsWorks? I mean, why is it hard to do things like scaling applications? And so, if you think about typical three-tier application where you have a load balancer, an app server which has your application or applications installed, or in an RDS database, if you want to scale your application, probably what happens is you receive a capacity alarm. So you find out that your application is either has too much CPU utilization on the app servers or too much memory utilization or whatever metric you're using to define as when your application performance is becoming degraded. And you alarm on that, and then you provision yourself a new server. And when you provision a new server, you need to then install whatever software is required. So if you have a Ruby app that's might be using Nginx. If you have a PHP app, there's probably Apache and ModPHP. You're installing all that software, then you need to get your app deployed. You probably need to install your database drivers. You need to finally send the database connection information, which hopefully you're not storing in your source code repository. And you even may want to have some separation of duties, so maybe your developers who are doing the deployment don't actually have that. And so you need to find the person to actually send that connection information. You need to get that app up and running and passing the health check, and then add it to the load balancer once it's passed the health check. So there's a whole bunch of steps that, if you receive that capacity alarm, you have to either script up yourself or do manually. And so with OpsWorks, what you do is you define your application and you define your auto-scaling parameters, and OpsWorks takes care of all the rest. It receives the capacity alarm, it provisions your server, installs whatever software you've specified, deploys the application, installs the database drivers, and securely sends your connection information from the database and connects your application to that database. Takes care of adding the new instance to the load balancer once it's passed its health check. Now you might be curious about database scaling. So probably folks on the call might be familiar with things like RDS read replicas. So RDS gives you a lot of tools to scale your databases. But when you scale out using RDS read replicas, then you need to be able to actually load balance among all those read replicas. And so today, some of the techniques people use are installing HA proxy, and then you would have to create HA proxy configuration files with RDS instances and health check your new RDS instances. So you would add and remove the RDS read replicas as you needed to. So it's a little bit of manual work, which with OpsWorks you can create an HA proxy layer and then add and remove the RDS read replicas from that HA proxy layer. And so OpsWorks would provision the HA proxy server. It would install HA proxy, create HA proxy configuration files for your RDS instances. It could scale the HA proxy to accommodate more load. And when you add and remove RDS instances, it could update the HA proxy configuration file for you automatically. And then, one of the things that, one of the things that's hard about deploying changes is that for any change that you might have, such as database credentials, source code, package updates, etc., you have to perform some sort of update on your instances. So you have to make sure that the person that's requesting it is authorized, get that change onto each server, and if you're running a fleet of servers like on your app tier, there might be tens or potentially even hundreds, depending on how big your app is. That's a lot of changes you have to coordinate. You have to perform the update, you want to verify it, and then you probably want to make those logs available somewhere. With OpsWorks, we handle those deployment updating tasks for you. So let me kind of just show you a demonstration so you can see what OpsWorks does and how it can simplify these tasks for you firsthand. So the screen I'm looking at right now is my OpsWorks dashboard, and this shows all of the OpsWorks stacks that I have running, as well as some information about them. I'm going to go ahead and click on the Add New Stack button, and basically all I have to do to create a stack is name it, so my stack. And a stack is a set of all the AWS resources that your application uses. So we'll create the stack and give it a name, select a region for it. I can select a VPC as well. And we'll pretty much use most of the defaults that are right here. I'm going to go ahead and take a quick look at the advanced area, which shows me this configuration management section. So OpsWorks also gives you the ability to specify the configuration of the EC2 instances in an automated and predictable manner, such as installing software and configuring RAID arrays and that sort of thing. Whereas in the past you might have run commands on your instances via SSH, you can now perform these tasks with predefined scripts that are called recipes that can be run remotely as often as you like. And you can even have OpsWorks run your recipes automatically at key points in the instance's lifecycle, such as after the instance boots or when you deploy an app. So to use custom recipes, we need to point at OpsWorks at our cookbook repository, which is stored on some repository out there. As I mentioned, OpsWorks supports Git and Subversion, so this could be your own Git server or Subversion repository, or one of the ones that's hosted publicly, for example, GitHub. So I have my cookbooks stored on GitHub, so I'll just go ahead and put my Git repository URL. I could put an SSH key if this was private, a branch or version number. I'm not using either of those, so I'll just go ahead and click the Add Stack. Next, we identify the major components of our application by creating layers. Now, a layer is a blueprint for your EC2 instances. It's the software that should be installed in the resources that it uses. OpsWorks supports a diverse set of application architectures by letting you define the layers you need. Now, my application that I'm going to demonstrate here today is a PHP application, and so we'll create our first, create the PHP layer. We'll also want to attach it to an RDS database, so why don't I go ahead and select my RDS database here, and I'll just go ahead and put in the user and password here. Now, let's take a quick look at what's inside a PHP layer. OpsWorks includes a number of things like predefined chef recipes that configure the instance with the software that you need, such as Apache and the PHP app server. And If I'm curious about it, what the recipe looks like, I can always click on it. These recipes are in GitHub as well, and they're open source, so I can see exactly what steps OpsWorks was doing to perform these configurations. Now, you can also add your own recipes to extend a layer. And so why would you want to create recipes for an existing layer? Well, the first thing that you can get with a recipe is consistency. Each time you call a recipe, it performs the same sequence of operations. For example, if your recipe creates a configuration file for an app server, it'll create the same one for each instance. The second is automation, which we talked a bit about in the presentation. So you can have OpsWorks automatically run your recipes to perform tasks on dozens or hundreds of instances with no more effort than just for one. The third reason is security. So instead of allowing SSH access to your instances, which is hard to control, you can specify who can run recipes, and the recipes specify what actions will be performed. And then the last is dynamic configuration, where you can have recipes specified to run in response to system events, allowing your environment to automatically respond to changes such as server scaling. We can also just do simple things like just specify packages that we want to have installed when the instance boots. So I don't even need to worry about creating any recipes to do this. And recipes can be as simple as just bash scripts or chef recipes. I can also create EBS volumes. So instead of having to create the volume separately, I can specify a mount point. I can specify a RAID level, a size that I want, and what the volume type is, including the recently announced general purpose SSD volumes. So this makes it a lot simpler for me than having to do the work of attaching volumes or elastic IPs manually. It's now just part of the layer configuration. And we can also do things like adding a load balancer that balances traffic to all the instances that are in this layer. So I don't have to worry about setting up and configuring the load balancer and attaching my instances to that load balancer manually. So the next step is to actually add an instance. So I'll go ahead and create an instance and start it up. And when I create the instance, it's configured with all the properties that I've specified in my layer. OpsWorks supports instances that are always on, time-based scaling for predictable loads, and then load-based scaling to be able to scale by CPU, memory, and load. The next thing I want to do, since I have a PHP app server, is I actually want to define my application. So this is my app. I can specify things like the document root. I can specify what the data source is. So here I have the RDS instance that I just attached as an RDS layer. I can tell where my application source is. So again, I can select Git or Subversion, HTTP or S3 archives. And the next thing I want to do is point it to my application, which is here in a GitHub repository as well. And in this case, I'm going to put in version 2 because I don't want to use version 1. I have version 2 of my app that I've checked in recently, and so I'll go ahead and put that in. So now that I have my app defined, why don't I go ahead and I'll switch over in typical cooking show fashion to a stack that's already working. So here I can kind of see a stack that has a load balancer, my PHP app server, my RDS instance, and on any of these I can take a look by clicking into it to see more information about, for example, my load balancer. I can see that all my instances are in US East 1A. I can see that 2 of them are in service and have passed the health check. I can also see a helpful warning that I probably want to distribute my instances across multiple availability zones. If I look at the RDS instance, a lot of this information is probably pretty familiar to you if you're using RDS today. Things like the whether backups are enabled, whether this is in multi-AZ instance. So some helpful things that are available right here inside OpsWorks. Let me just kind of mention next deployments, because now that I've defined my application, then I probably actually want to deploy it. So I click on the deploy an app. I can select an app The deploy is the default command, although we can also see we have things like undeploy, you can stop and start web servers, but we'll go ahead and just go with deploy. And I can see that I can also select the instances I want to perform the deployment on. So perhaps one of your steps before you deploy to all the instances in your stack is you just deploy to one instance and just verify that the deployment looks good, and then you go ahead and deploy to the rest. So we can kind of kick that off. And so we can see that the deployment's running on our PHP app1 instance. Once that deployment's finished, I'll see a log file here. So why don't we not wait for the deployment? We'll go ahead and move on to the next part of the demo, and I'll come back to the deployment so we don't have to wait for that. The next thing I'll show is the monitoring view, which shows my instance's CloudWatch metrics aggregated by layer. So you can see that I have two layers here, PHP app server, and I also, in this stack, have a Ganglia monitoring server. So I can actually see more detailed metrics from Ganglia. So again, OpsWorks lets you create a variety of layers which correspond to the components of your application. So you're not really limited by just app servers. You can also create a whole bunch of different types of layers for things like logging and searching and workers and any other sorts of components that are inside your application. So let me just kind of take a quick peek into one of the layers, the PHP app server layer, by clicking on it. And I can see the two app servers I have running. And if I were to click on one of these, I can actually see a bunch of the individual metrics that we're summarizing. So we're getting metrics from the instance itself. And so that's how we're able to see things like the memory utilization, a whole bunch of detailed metrics on CPU and load that could be useful for you. And these are also put into CloudWatch, so you can create alarms on these. And they're also what's used for the load-based auto-scaling. Finally, I can specify who can perform actions in the permissions view, including which users are allowed to SSH into my instances. So I can give Mary the ability to deploy applications, but she wouldn't necessarily have the ability to manage my stack resources. So she couldn't create or delete new EC2 instances. Whereas I could give my manage user full manage rights and also allow that manage user to SSH and have sudo rights. So this supports delegated administration and resource level controls of what users can do in each OpsWorks stack. So with that, let me just go back to deployments, and we can see that my deployment completed successfully. If I wanted to, I could even see the log on the instance by clicking on the log. So I don't have to SSH to my instance to see a full log for what happened during that deployment, which is pretty handy if you end up having a deployment failure. You don't have to log into the instance to be able to see what went wrong. You can see it right here from the management console. So with that concludes the demonstration of AWS OpsWorks. Why don't I go ahead and I'll take some questions now. So if you're interested in providing questions, go ahead and enter those in the Q&A panel.
Thanks, Chris, for the informative presentation, and to the audience for submitting great questions. As Chris reviews the questions, let's launch today's poll. In your browser, you can see a poll pod. Please take a moment to respond to a few survey questions which evaluates today's presentation. What is the topic you want to learn next? How effective was the presenter in communicating the content? Then lastly, overall, how satisfied were you with today's webinar? All right, thank you, everyone. The feedback is greatly appreciated and will help us improve the webinar platform. So we'll now start the Q&A. Continue entering questions if you have any, and Chris will get started with answering the ones already submitted.
So thanks. A lot of good questions here. I think I see a few that are asking a little bit about Beanstalk and OpsWorks. So I didn't mention it in this presentation, but Elastic Beanstalk is also another application management service. And the key distinctions, or the key way to think about, should you use OpsWorks or Beanstalk, is that Elastic Beanstalk is a container-based application management service. And what that means is that it's very easy to get up and running for a particular application configuration. So if you, for example, are using RDS and an app server and a load balancer, that's really kind of the sweet spot for Beanstalk. So if that's kind of exactly how your app is configured, then Beanstalk could be appropriate for you. Where OpsWorks really shines is if you need to customize that configuration in any way. So if you need to use a different app server version, if you want to use a different operating system, if you want to have control over the pace of updates, if you want to use something like Ganglia, like you saw in my demonstration, or a particular caching layer, OpsWorks lets you configure layers for really any software that's scriptable. And so you're able to install and configure and change the configuration of your instances as you see fit. So a lot more flexibility and customizability. But if you don't want that customizability, then Beanstalk could be an appropriate option for you. Another question was around CloudFormation. And so CloudFormation today supports both Beanstalk and OpsWorks, as well as almost every other AWS resource. So where CloudFormation really shines is around provisioning your resources. And then, operationally, if you want to kind of manage your app, like deploy new updates or view the CloudWatch metrics or handle the permissions of who's allowed to deploy and who's allowed to create, that's really an area where OpsWorks shines. So you could imagine creating OpsWorks stacks in the context of your RDS databases, your all the elements of your stack, like your caching layers, your app servers, your Elastic load balancers, your VPCs, and your subnets. All that could be created and provisioned with a CloudFormation stack, but then you would manage all that. You could manage all of it through the OpsWorks management console. Another question is Puppet. So you can see through the UI, and as I mentioned, Chef is currently supported with OpsWorks. We do listen to customer feedback to prioritize our roadmap. So great to hear that folks out there are interested in Puppet as well. We listen to it not only through channels like this, but you can also, there's a thread in our forums. You can kind of put your requests inside there, and we do use that to prioritize where we're going. So thank you for submitting that. So the question on, we currently use CloudFormation templates for provisioning can be easily convert to Chef cookbooks. So like I said, you could use CloudFormation with OpsWorks if you are provisioning the software inside your instances using CloudFormation. You're probably using something like a bash script, which you can also use with OpsWorks. There's a blog on that OpsWorks participates in where we actually have one of our blog entries on how you can use bash scripts with OpsWorks, and so it's pretty easy. It would be easy for you to kind of lift your bash scripts, put them into an OpsWorks recipe, and then use that if you're interested. So I can point you before we get off this call to where the blogs are. A question on supported app servers. One user was asking about PHP versions, if we plan on supporting PHP 5.5. And the answer is we do have plans to do that, so stay tuned. I don't have a delivery date I can give you, but I can tell you that is something we do want to support. Question on OpsWorks built-in recipes, are they public or private? So as I showed in the demonstration, you can see all the recipes that are part of each layer when you select the layer. And if you click on any of those recipes, then it links you right to the GitHub repository, which is a public repository where the recipes are. So you can fork those if you wanted to. We are happy to get stars and pull requests, so please feel free to take a look at our recipes and use them as you see fit. A question on, is it possible to run a PHP app and a Tomcat app on the same instance via OpsWorks? The nice thing about OpsWorks is basically anything that's possible to do on an EC2 instance, it's possible to do with OpsWorks. The benefit with OpsWorks is you can script it using Bash or Chef recipes, so you can then automate it and have it be predictable every time you do it. So if you have a configuration where you run a PHP app and a Tomcat app on the same instance on EC2, then you could do that on OpsWorks as well. And you may even be able to use some of the built-in recipes and extend those. So for example, today the PHP layer installs Apache. I think that we have a Java Tomcat layer as well. You might be able to kind of take those recipes and combine them, but that's not supported in our current built-in recipes, so you need to use the custom recipes to do that. The question on using custom AMIs. So OpsWorks supports custom AMIs today. An AMI is an Amazon machine image, which lets you, it's basically think of it as the root volume and other volumes that you want to have attached to your EC2 instance, and then any software you've installed. Now, by default, OpsWorks uses a base AMI for Amazon Linux or Ubuntu, and then you layer software on top of it using recipes. But if you have some software that doesn't really change much, you might want to consider baking that into an AMI, and you can do that with OpsWorks. So you can, if you have, for example, maybe your Apache version doesn't change, but every 6 months, you don't want to have to install it on instance boot, then you could bake that into an AMI and use that base AMI. And so a question on recommended mechanisms to avoid storing DB credentials in application source. So that's a great question. Why don't I actually flip back to my demo to kind of show you a little bit about that. So I think you might have seen when I created my RDS layer, it let me specify the credentials for my database. So my username, and then if I want to update my password, I can enter it here. So these credentials are now stored securely on the OpsWorks service, and so you don't need to store them inside your source anymore. They're stored by the service, and they're then passed to your instances at boot time, and only to the instances that actually need access to your database. And then you can reference those in your application. So let me kind of just show you a potential way of referencing those variables. They come down in a JSON format that we actually have some built-in recipes for our app servers, so you can reference them pretty easily. But if you wanted to reference them in a custom application, maybe a cron job or something like that, you could also reference them. So you can see, the database host name, the username, password, the database table that you're using. They're all available here inside these attributes. And so your database credentials don't have to be in your source code anymore. In fact, you wouldn't want to have them be there. You instead would want to reference the credential and connection information that we're sending down to the instances for you. Question on, is there any current support for Docker? So we were actually at DockerCon last week, and we have a nice presentation that you can reference from there. Because OpsWorks really can support any application that's scriptable, you could create a Docker layer for OpsWorks. And the nice thing about OpsWorks support for Docker is you can deploy multiple Docker images to your Docker container that's running on an EC2 instance. And you can also take this metadata that we're sending down to the instance, and you can put it into each of your Docker containers as well, so that you can have access to, for example, the database credential information. And so you might want to take a look at that presentation. It kind of talks through how you would create a Docker layer and how you'd use etcd to get that metadata that's being passed down from the OpsWorks service to your instances. So question on data bags and Chef. We do have support for data bags. Probably don't have time to dig into it in this call, but there's some information about how to use data bags in OpsWorks in the documentation that you can reference. And if you have follow-up questions on any of these things, we actively monitor the forums and encourage you to please ask your questions there, and we'll get back with you with answers. Question on just use Jenkins for deployment. How does it work with OpsWorks? I actually have another demo that's available on YouTube where I show using Jenkins for continuous deploy with OpsWorks. Essentially, what I did in that demonstration that I'll summarize here is I used a deploy hook from my repository to trigger a build on Jenkins. And then when the Jenkins build succeeds, then I deploy to my staging environment using the SDK, the OpsWorks SDK. So it's pretty easy to create deployment pipelines. Again, this is all in the spirit of automation. So you always know that when you perform check-ins that developers do are immediately compiled. If those compiles fail, then the developer will get a message, and then you send it to your staging environment where you can run your integration tests that you probably have in Selenium or whatnot. And if those fail, then again the developer can get an update. So you can kind of, instead of waiting weeks or months to find out if a check-in's caused some sort of failure, you can find out pretty quickly. So definitely love that pattern of using tools like Jenkins to do continuous deployment. Question on OpsWorks compatibility with says with Windows EC2 instances. Today, unfortunately, we do not support Windows. Again, we're very eager to prioritize our roadmap with customer input. So thank you for providing that piece of input, and just to let you know that as well. Question on can stacks be shared or moved to another Amazon account? Probably the easiest way to share your stack is to use things like CloudFormation. So one of the benefits of CloudFormation templates is you have the ability to basically create a text version of all the resources you're using, including your OpsWorks resources, which you can then check into your source repository and share with anyone you want. Question on parameters you can use to scale up with automatic instance scaling. Today, it's only CPU, memory, and load. You can also scale up and down with time. So you can, if you have predictable loads, you can use time. We don't have custom metrics added, which was the second part of that question. Can OpsWorks instances be sized? The answer is yes. Basically, any EC2 instance type and size is available to be selected from OpsWorks. So anything from T1 micro to some of the largest I2 instances you can use with OpsWorks. Question on if we create our own recipes and use them in OpsWorks, are they private, and can we make them private? And the answer is yes. So as I showed, you can reference your repository, whether that's a private S3 bucket or a Git repository or a Subversion repository. That could be even within your own corporate firewall that's just accessible through your VPC VPN tunnel. Or it could be a repository like GitHub, but you make the repository private and you give OpsWorks your deploy key. So there's a number of ways to use private repositories, and those are described a little bit more fully in the documentation. And then is there a place where we can simulate chef recipes for any errors? There's actually quite a bit of good tooling in the chef community, things like Test Kitchen to let you try out your recipes. I'm kind of working on a blog right now that gives a little bit more direction on that, but that would be probably a good place to start if you're interested in trying out chef recipes. That said, it's pretty straightforward too to use chef recipes in a virtual machine or on your own development environment, or just use them on EC2 as well. So don't see any other questions. This has been a lot of great questions. There is one question on sharing the slides. Okay, I'll let Aaron finish up here. Thank you very much.
All right, thanks again, Chris, for taking the time to speak with us and present. I'd also like to extend a special thanks to all the attendees. Within the next day or two, you're going to receive an email with the links to the webinar recording and more information. If you have any comments on our previous and upcoming webinars or suggestions on topics you want to see, please email aws-webcasts@amazon.com. Your feedback is great, and it helps us improve these webinars. Again, thank you for taking the time to join us today. Enjoy the rest of the day.